Good morning. We are going to there's a lesson in Delta Math. It's titled Definition of a Derivative a second. Just realized it's raining like crazy or snowing out there right now. But definition of a derivative and tangent lines. So with this, we're going to go way back. This is back to the beginning of what we did this year, and look at a couple different things. The first thing is when you're asked, and we've talked about this several times, when you're asked for the average rate of change, you already should know what I'm going to ask next is what should you think of? And hopefully you know that that is just the slope. So when you're talking about the average rate of change, you're talking about the slope as you learned it in geometry or algebra, whenever you learned it. But we would do f of b minus f of a divided by b minus a. So the y2 minus y1 over x2 minus x1. And so that's the average rate of change. So like if you were asked to, if, for example, you're given something where, I don't know, where they said f of x was equal to x squared, find the average rate of change on, I don't know, 1 comma 4. So if you were finding the average rate of change on 1 comma 4, what you would do is you would actually go through and you'd do the average rate of change is equal to 4 squared minus 1 squared over 4 minus 1, and whatever that works out to be. So that's pretty easy, right? Hopefully that's really easy for you. Now, something that we might have breezed over a little bit in first semester, and something that we're gonna really need to kind of look at a little differently, and that is, or look at a little more in depth, is because I think they might ask a question like this on the exam. I certainly was going to cover it. I know it would have been a multiple choice. Not sure whether they'll put it on a on a free response question. They might, especially in that first free response question. But that's the definition of a derivative. Now, if they ask you for this, they're basically going to ask you just to set it up but not evaluate it. But the definition of a derivative of some function f at point is found by the following. F prime of x is equal to the limit, as h is usually what they'll use, as h goes to 0, of f of x plus h minus f of x divided by h. So what they're doing on that is they're really just saying, okay, if we have a function, if I draw a little function and we are finding maybe the derivative right here at this value right here, we could take and we could say, okay, here's x. If we took another point right here and called it x plus h, we could take and find the line between those two and look at that slope. And look at that slope being f prime. If we then think about what would happen when h goes to 0, those 2 points, the blue one and the red one, kind of squeeze together. You know, if you think about the red one being right there and the blue one being right there, they kind of squeeze together. And if they squeeze together to 0, then you're really just calculating the slope, because the top is y2 minus y1, the bottom is x2 minus x1. Now they're just going to ask you to set it up. They might ask you to do something like, for example, they'd say, you know, given f of x equaling x squared plus 3x, find f prime of x using the definition of a derivative. And so if you were to do that, what you'd do is you'd say, okay, well, I just have the limit as h goes towards 0, and literally what we would do is we would do x plus h squared plus 3 times x plus h minus x squared plus 3x. Do need parentheses around that second half because there's some subtraction out in front, divided by h. And then we could go through and simplify it, and we'd find out that it equals 2x plus 3 if you really took the derivative. But we wouldn't really have to go through and simplify it. Just writing it out, that's all you'd have to do. That's using that definition of a derivative. All I'm done is plug stuff in there. And if you look at the way that looks, that first part is f of x plus h. The second part is just f of x, and it's divided by h. And so if you look at that and you do a problem on Delta Math today, that's really where how you're going to do that problem. And you won't have to simplify it. You just have to shove it in there and kind of see what it is. You know, if we make x equal to a specific value, we could throw the value in there. You know, if we wanted to do it at x equals 4, we could throw that value in there and get it. Any questions on that? Hopefully, if you have questions, you show up at office hours. I'd be glad to help you. I know you can't really ask questions right now. So that's the first thing. Remembering that we have that basic power rule for derivatives, where if you're asked to do the derivative of something like x to the n, remember that's n times x to the n minus 1. Remember that rule. And know that when you're asked to find the slope of the tangent line, that is just simply the derivative. Remember that is just the derivative at some x value. If you're asked to write the equation of a tangent line, usually you'll be given some point. Maybe the point is a comma f of a. So when you're asked to write the equation of the tangent line would be y equals f prime of a times x minus a plus f of a. So you got the slope and you get the point. It's the same thing you've used throughout when you were doing problems in elementary school even, or maybe in 8th grade when you were doing linear stuff. So think about like this. Think about if I did an example and I said write the equation of tangent line to f of x equaling 3x squared plus 4 let's do 4x at x equals 2. So say I had you do that. Well, so one of the things you're going to need is you're going to need that point. So you'd have to kind of say, okay, well, f of 2 is equal to 3 times 2 squared plus 4 times 2. So 2 squared is 4 times 3 is 12 plus 4 times 2 is 8, so you got 20. So you got this point 2 comma 20 right now. And now you need the slope. So you know f prime of x is just equal to 6x plus 4. So then if you kind of transfer that into the specific x value we have, we'd have 6 times 2 plus 4, or 16. So our tangent line then would be y equals 16 x minus 2 plus 20. And you don't need to simplify it. Leave it alone. I'm pretty sure you're going to be asked that on the AP exam, to write the equation of a tangent line. It's something that we've done several times. It's got a lot of good calculus stuff in there. I would guess that that's something that you're going to have to do. With regards to, going back to the slope of the tangent line is this f prime of c. That's the slope of the tangent line. Know that if you have a vertical tangent, f prime of x would be undefined, or it would be does not exist. For a horizontal tangent, f prime of x would equal 0. So if you're asked to figure out when something is a vertical tangent, that's when it's undefined. When you're asked if something has a horizontal tangent, that is when the derivative equals 0. There are some other places where f prime of x does not exist. And f prime of x does not exist at sharp changes in the graph, f prime of x does not exist if the graph goes vertical. F prime of x does not exist if there is a jump in the graph. And f prime of x does not exist, you should hopefully note the last one, is if you have a vertical asymptote. So when you think about ways I can draw all these things, if I label them, 1, 2, 3, 4. So if I label them 1, 2, 3, 4 and kind of said, okay, what are they going to look like? Sharp change in the graph. That might be if the graph kind of goes up and goes back down like that. The second one, when the graph goes vertical, looks like this, and then it goes over here. So when you're talking about where doesn't it exist, it doesn't exist right there. F prime of x doesn't exist right there because the slope is undefined. Third one would be if there's a jump in the graph. So if the graph kind of comes in here, goes like this, goes up to here, right there. At that jump, there's the graph, the derivative does not exist. And then the final one, you kind of know what that looks like. That's where if the graph goes vertical here. Maybe it even goes vertical that way. It doesn't matter, but there's an asymptote. So those are really the times when the derivative does not exist. So just remember that can happen. And I think that's enough to get through that assignment. There's an assignment on Delta Math. It's 16 problems. The ones that might give you some issue or some pause is the ones when you're using the definition of a derivative. Remember, if you don't get one, you can give up on it, get the solution to it, and then go back and look at it and see what it looks like. Then you should be able to emulate that in your work. If you have any questions, please jump on at 1:30. Happy to answer your questions. I usually can get things done really quickly with you. We can share our screens. Make sure you get on there. Keep up with the work, and continue to work on that big cheat sheet. The definition of a derivative would be a great thing to put on that big cheat sheet. Good luck, and I will see you soon.